Hi, I'm Kris and I'll be your English teacher for today. Today's lesson is all about our friend the sun. It's getting warmer out, and so we'll take a look at how the sun is playing a part in the rising temperatures. Okay, first, what is the sun? The sun is, like anything else, everything around us, everything we see is called matter. Matter. Now, normally when we think of matter, we think of three different states: solid, liquid, gas. Solids are things that are hard. We can touch them, we can put them in a container, and they will not change their shapes. Liquids, these are like water. If we pour them in a container, they will take the shape of the container. Gas is like smoke or the air around us. We can touch it, we can feel it, we can't always see it. Now, when we talk about which of these the sun is, most persons say gas. But they're wrong. The sun is something completely different. And this word you won't have to learn, probably, because at this point it won't really be too helpful. But just to show what the sun is, its state of matter is called ionized plasma. Now, what is ionized plasma? I don't even remember because it's not important. All we need to know is that the sun is not really a gas. Neither is it a solid nor a liquid. Alright? Now, here's our sun. How does the sun produce daytime and nighttime for us here on the earth? Well, when we are facing toward the sun's light hits our side of the world. So our side here, where the sun is hitting, is bright. But the earth does not sit still. The earth is constantly spinning. And when it spins, just like a ball, this is called rotation. It is rotating. So when the earth spins, different areas get hit by the sun. So let's say for a moment that the earth is here. Now, let's say where we live facing toward the sun. When light from the sun hits our house, hits where we live, it is daytime. But when the earth spins and we are now on the other side here, then the light will be hitting the other side of the earth, not where we live. So where we live will be nighttime. We won't have any sunlight where we live. This is how the sun is able to make daytime and nighttime. When the sun is beaming on the earth, it is light out. But when the earth begins to rotate, then the sun shines on different parts. That is why when it is nighttime here, it's daytime in China. And when it is nighttime in China, it is daytime here and we have the sun out. Okay? Okay? Another thing that causes us to feel the warmth of the sun is our location. During the winter time, we are far away from the sun. But as the seasons change, the earth moves closer and closer and closer to the sun. So when we are here, we are a lot closer and there is more heat being sent to the earth. But when we are farther away, not as much is able to reach us. And when the earth moves around the sun to create the seasons, this is known as a revolution or revolving. And this is what allows the seasons to change. And as we move into summer, again, we are becoming closer and closer to the sun. Okay? Now, let's say this is the ground. Here is the sky. All this here is outer space. And here we have the sun. Alright? Now, when the sky is clear, the heat from the sun radiates down onto the earth. That is when the heat from the sun is sent here. That's all that means. And it warms the earth, but also it leaves as well and goes back out of the earth into space. But when there are clouds, when we have clouds in the sky, it's different. If the heat from the sun strikes the cloud, then it is reflected. What the cloud does not keep is sent back into space. And if the heat from the sun hits the earth, reflects, and then touches the cloud, it will be trapped on the earth. And that allows some of the heat to stay. So even when it is cloudy, it can be warm because the heat is trapped. But if there are many clouds in the sky, if we have many clouds, very cloudy day, then it will usually be cooler out. That is because a lot of the heat from the sun cannot reach the earth. Another name for radiation to radiate is to emit. You might hear me say to emit heat, because that's exactly what the sun is doing. Okay? Now, to understand how this is able to actually warm us, we have to understand something about heat. Normally we like to think of heat and coldness as two separate things that work against each other. But in reality, coldness is more of an absence of heat. Why? Because when the sun is very hot and the earth is nowhere near as hot as the sun, it is the nature of heat to travel from a warmer thing to a colder thing. The earth. The earth is a lot colder than the sun, so a lot of the heat from the sun is sent out into the earth. Does that make sense? I'll show you something momentarily that should help make this clearer. But it is true for anything, any piece of matter has energy, some kind of energy. And what happens with heat? It is a transfer of this energy from one thing to another. To transfer means to take something from one place and send it to another. So what happens with the sun, again, is that the heat that it emits or radiates or gives off is transferred to another object, in this case the earth. It is the same for all things that exist. Anything that is matter gives off energy, and this energy is heat. It is what we call heat. The only difference is that the sun happens to have a lot of heat and that's why it's a lot easier to see with something like the sun than it is for something like this eraser. But even this eraser is capable of emitting heat to something that is colder than it is. Does that make sense? Okay. Now I'll show you a small experiment that demonstrates how heat is transferred. Okay, now I will show you how heat is transferred in a small experiment. Do not try it at home because it is somewhat dangerous. Okay, have a marshmallow. I'm going to light the candle here. Alright. Now, without touching the fire, I am going to hold the marshmallow very close to the source of the heat, and we'll see what happens. Alright? So, as you can see, the heat was transferred to the marshmallow. It caused it to catch fire and leave a small burn. Now, we did not touch the marshmallow to the fire. So why did it happen? Again, it is because the marshmallow is colder than the fire. So the heat from the fire was transferred from the source of the heat to the object that was colder, which was the marshmallow. Even though it did not touch the marshmallow, the heat was able to travel through the air, which is a gas, into the marshmallow, which is a solid. And by doing this, it was able to burn the marshmallow. I'm going to shove this whole thing in my mouth. Oh.